Because the ages between two like atoms that are more electromagnetic than the other. Yeah, that's no, go to sleep, dude. And actually, and then like for the after lab, we should go to that SEMA thing. So not doing too much. Just like, is that okay? I heard the next farm tech program starts soon. It's like I don't know if you're reading this program. I mean, you don't have to. You could just kind of like, if you find a place that'll just hire you on the job, and then you can just pass the test. It's a lot cheaper that way. Like I feel like it's like yeah. It's like you can pass the job. It's too much. I feel bad that Is that what you're doing right now? At the mall or at the fridge? Morning. It's you. Oh, okay.
Okay, so I think we've completed the section of Chem1B on structure and bonding. So we looked at organic compounds and some biological molecules. Now we'll talk about solutions. And today in lab, you'll start lab 2, which has to do with solutions and solution process. So I hope that you and your lab partner brought some coffee, beans,
How much coffee do you drink?
not much.
Oh, not much.
Yeah, I'm sure, but it's going to be pretty good.
Okay.
Like 5, 6 minutes. You're not going to make, a big carafe of coffee. Several small batches.
Okay.
Okay, so let's review what we know about solution. Now remember, when we classify substances, we can either classify substances as pure substances or as mixtures. So most substances turn out to be mixtures, and the chemical companies spend a lot of time and money and energy trying to separate mixtures into pure substances. So by learning something about how to separate mixtures or how to use solutions, we can do quite a few things. Okay, so let's talk about the first question. A solution consists of A, solid or a liquid. I see. A solid and a liquid. B, a solute and solvent. Or C, a solvent and a substance. So is it A, B, or C? B. Who says it's A? Who says it's C? Okay, good. You're right, the answer is B. Now, in Chem1A, we said that the solubility of one substance and another depends on polarity. So we looked at that like dissolved like rule. That means that a polar substance dissolves in another polar substance, a nonpolar substance dissolves in a nonpolar substance, but a polar substance does not dissolve in a nonpolar substance, or a nonpolar substance does dissolve in a polar substance. So we can predict, based on polarity, whether one substance is soluble in water. So, based on polarity, is sodium chloride soluble in water? So we know that because we've seen that before. It's salt in water, so. Is oil soluble in water? And why isn't oil soluble in water? Because what's non-polar? Oil. Okay, so the oil is non-polar and the water is polar. So we expect oil not to be soluble in water. Is gasoline soluble in oil? And why is gasoline soluble in oil? Because yeah, so is gasoline polar or non-polar? It's non-polar. You said oil is non-polar. So we expect gasoline to be soluble in oil. Now, in Chem1A, we also looked at that solubility rules table. That's in page. In the textbook. That's on page 100. That's on page 101. Table 4.2. So the solubility rules table tells us what type of ionic compounds are soluble in water. So, for example, it says compounds containing alkali metal ions and the ammonium ion are going to be soluble in water. So, based on that, we know that sodium chloride, which contains sodium ion, should be soluble in water. Nitrates, bicarbonates, and chlorides are all soluble in water. Now, halides, the chlorides, bromides, and iodides are soluble in water. There are some exceptions, though. Silver chloride, mercury chloride, and lead chloride are insoluble in water. So those are ionic compounds. Ionic compounds are polar. So it turns out that not all ionic compounds are soluble in water. So why is it? Okay, so let's go to the next slide. So in Chem1B, we'll look at this like dissolves like solubility thing in a little more detail. So the solubility of one substance to another can be explained depending on whether it's a ionic solution or a molecular solution. So if you're looking at an ionic solution, you're going to look at these two terms, lattice energy and hydration energy. Okay, so lattice energy is the amount of energy required to break the ionic bonds in an ionic solid. So if we have, for example, the sodium ion and the chloride ion. Okay, so these are held together by what chemical force? By what? Yeah, ionic bond. So lattice energy is the energy required to break that ionic bond. Okay, I'm going to draw a few more of these. I'm going to draw a few more of these ions on in this little picture. Okay, so here's another chloride ion. Here's a sodium ion. Hydration energy is the energy released when a water molecule hydrates an ion. So if here's our water molecule, okay, so this would be our sodium chloride solid. Here is a water molecule. So the water molecule is going to interact with, say, a sodium ion. And if there's enough water molecules, a water molecule can carry away that sodium ion. So what happens is that the sodium ion is going to leave, and it will be hydrated. By water. Okay, so hydration energy is the energy released when an ion is hydrated by water. And the same thing is true with chloride. So in case of chloride ion, Okay, so here's our chloride ion. It can be hydrated by water. Okay, so these water molecules can carry away the chloride ion. Okay, so in that case here we have the chloride ion, and it will be surrounded by these water molecules. Okay, one more thing. Note that the sodium ion is attracted to the oxygen, whereas the chloride ion is attracted to the hydrogen. So why is that? Because hydrogen has what?
Partial positive.
Yeah, so hydrogen has a partial positive charge, which means that the oxygen has a partial negative charge. Okay, so that's why the negatively charged chloride is attracted to the positively charged hydrogen. In the case of sodium, the positive sodium ion is attracted to the partial negative charge on the oxygen. So when we look at solubility of ionic compounds in water, we have to compare lattice energy versus hydration energy. So sodium chloride is soluble in water because the hydration energy is greater than the lattice energy. Okay, so in other words, the amount of energy released when these ions are hydrated is greater than the amount of energy required to break the ions apart. In the case of silver chloride, which is insoluble according to table 4.2 in the textbook, silver chloride is not soluble in water